right, in this lesson we're going to look at linear and quadratic regression models. First we need to know what modeling is all about, and modeling is just a process of looking at some data and making an equation that fits it. And when we make an equation that fits some data, we want to know something about the correlation. The correlation is how closely it fits. If a model fits perfectly, or an equation fits some dots perfectly, then it has a high correlation or a strong correlation. So if we have some points, maybe we collect some data from a scientific experiment, and we can find some equation that perfectly fits them, then that has a strong correlation. So we're going to see how we can use our technology to do this for this, because there's a lot of number crunching that goes on. And so normally we're used to taking an equation, y equals 2x plus 3, and we're used to getting points from the equation. But now we're going to go backwards, and we're going to get the points, and we want to find the equation, and we call that regression. We're going to regress, kind of going backwards. And the equation we're going to get is called the regression equation, going backwards. Okay, here's some steps for entering data onto our calculator and onto a TI-83 or an 84. Okay, so there's those steps, and in the video you can come back if you need to look at these here. So the key is we're going to go to the stat button, and we're going to enter some data, and then when we're done with that, we're going to come and we're going to use what's called stat plot. Okay, so the stat button is where we enter the data, and then we're going to get a stat plot and set that up and graph it. Okay, and then when we want to do regression, we're going to come back to stat, and we're going to use calculate. That's the big idea. So here we want a scatter plot for this data. So we're going to go to our calculator, and we're going to enter the data. The way we do this here is we're going to go to stat. Okay, so hitting the stat button, we're going to go to edit, enter. Okay, now you should have L1 and L2 up here. If for some reason you don't, like it looks like I'm missing L3, down above the 3 key is L3. So if you go up here, if you go on up here, and then you type L3, like I'm about to do here, then it'll work. Okay, so anyway, you should have L1 and L2. So let's enter the x's in here, 1, 2, 2.5, and 3, and 4, and 5. So we enter that data in there. Then we enter the y's in our second column there. And then we've got them all entered there. So we've entered our x's and y's, so the calculator understands that. Our next step is to go to stat plot, which is right up here. So we want to use stat plot, and so we're going to go second stat plot. Okay, here's a bunch of plots. We want to use the first plot. The important thing is to turn it on. If you don't turn it on, you won't be able to see it. This right here is our scatter plot. So we want to use our scatter plot there. So it's all good. So we're going to go down. X list and Y list. These should automatically say L1 and L2, but mine don't. So down here above the 1 key, I'm using L1, and I need to type L2 here. So I'm telling the calculator that my X is in the list 1 and my Y's are in list 2. That mark is fine. And now if we go graph.
Selena D. Contreras, please come to the front office.
Now if you have any.
D. Contreras, please come to the front office.
If you have any equations in here, you got to get rid of that. That's why I had a little problem there. Okay, so now we've got the points, but you don't see all the points. So the next step is to go to zoom, and zoom stat is what we want. There it is. It's number 9. You can either type 9 or hit enter. And there it is. Now we got a good picture of it. There's our scatter plot. So we're going to copy this down over here, okay, approximately. So we've got these 2 points, something like that, okay? Now, next step we want to do is we want to find a linear regression model. We want a model is an equation. Okay? A model is an equation. It has nothing to do with getting fancy clothes on and walking around and being a model like that. So a model is an equation. So that's what we want to find. So we're going to go here. We're going to go to the home screen so we can quit out of here. We're going to go to Stat, Calculate, and what we want is we want a linear regression. That is number 4, lin regression. So we went Stat, Calculate, now we're at linear regression. Enter there. We've got to make sure our list 1 and list 2. Somehow mine got changed, but that's a good example here. That just make sure it's list 1 and list 2. Don't worry about frequency list, okay? And one more thing that we're going to want to do here is this. We want to store the regression equation. We want to save it. And so what we need to do is we need to tell it that we want y1 here in this spot. So where we're going to find that is we're going to find that under the vars key right here. Okay? So on the vars key, we're going to go variables, vars for variables. We want y variables. We want function, hit enter, and y1. Okay? Vars, y vars, function, y1. Okay? And then we can calculate. Now, if you have an older calculator, it'll be a little different. You can look it up how to do that, or I can help you in class. And we'll calculate. There it is. So what this means here is this means that we have an equation in slope-intercept form, and this number right here is the A, and this number right here is our B. So this equation is about y equals 3.94, I'll round off that 3x, plus, watch out for this negative here, so it's actually a negative sign,
Kaylee, Tilden,
minus
Whitler's room.
0.07. Okay, so 394x plus minus 0.07. Let's write that down. Y equals 3.94x minus 0.07. So now we've got our equation. Okay. Now the reason why we stored that regression equation is if we go to the y equals here, there it is. It's all in there already. Okay. So our equation is stored for us. You didn't have to type all of those numbers. That would be a pain. So it stores it nice and accurately for us there. And we're going to need that here in a minute. Okay? So now we've got our model. Okay? And one thing we need to point out there again is the R value, the correlation. So let me go back real quickly to Stat, Calculate, and let's get our regression again. Okay? And this R value here, okay? This R value tells us how accurate it is, the graph is. And if this is 1, then its correlation is perfect. But it's close to 1, so this is good correlation. Okay? Or we call it strong correlation. Okay? So the R value is 0.98. That means it's a strong correlation there. Okay? So now we want to predict the Y value when X is 10. So we've got this model, and we want to know, well, what should we expect when X is 10? What goes over here? So we just need to plug 10 into the equation. Well, our equation has this big old decimal. All right? And so we got a couple options. We could just write this out by hand or type it and plug 10 into here and say 3.938, if I round off 8 times 10 plus this B value, which is negative 0.0714, and we could calculate that out. That would give us our Y value. However, that's going to take a little bit of work, okay, of typing and rewriting and remembering all that. So that's why we put it into our Y equals, and there it is. Okay? And so
Patrick, please go to the bookkeeping office.
what we can do is let's go to our variables, vars, and go to Y vars, go to function, Y1, okay, from the home screen, and we want to find, this is like finding f of x. So we want to find f of 10 is what we're looking for. And so you can come in, Ethan, that's fine. Just recording. You can come in. Okay, and so if I do this, that's just taking 10 and put it in this equation. We just put 10 into this equation. The calculator figured it all out for us, and it figured out that when 10 goes in, 39.3 comes out. Okay, so 39.3 is what we would expect when x is 10. Okay, so when x is 10, so we got y1 of 10, or f of 10 we could say, is, and what did we say there? Whoops, wrong one. It is 39.3, okay? 39.3, all right? Now, sometimes data fits a line, but sometimes it fits, we need a quadratic equation. Well, it's the same steps, but now we're just going to use a quadratic regression, and we'll just use a different key. So let's do that one more time. We've already entered our data here, so we don't need to enter it again. And but what we just need to do is we need to go back to Stat, going over to Calculate, and we're going down to Quadratic Regression, number 5. So quad there meaning quadratic. So we're going to get an x squared equation here. That's a quadratic, right? So we go quadratic. We want list 1 and list 2. We got it. That's good. Don't worry about the frequency list. Okay. And we want to store the regression equation. We're going to go vars, y vars, function, and enter for y1. There we go. Because we want a new equation. So we calculate, and there it is. So there's our A, here's our B, and there's our C. And so this is the equation y equals 0.34x squared plus 1.87 or 88x plus 2.47. So let's jot that down. So we have y equals 0.34x squared plus, and we have 1.88 x, and that last one was a plus 2.48. Okay. The r value, in this case it's a capital R, r squared. Okay, don't worry about why that is there. It has to do with the fact that it's a higher power than 1. So it's 0.98, and that's a pretty close there. Okay, so r squared is 0.98. Again, if that's close to 1, then that means there's a good correlation. And last thing here, let's find out with this equation what happens, or what is our prediction when x is 10. So when x is 10, now let's go back. There's that big old equation. Again, it's written all these numbers in, more numbers than you would want to copy down by hand. So it's all there because we stored the equation. And so what we want to do is that's in y1. We're going to go to the home screen, and we're going to go to vars, y vars, function, y1, and we want to find y1 of 10, which again is like f of 10. And there we go. Okay, and we got 55.2. So the whole point is this, that if we use a quadratic expression, we get 55.2. We would expect something different. Let's name this different. Let's call this g of x, and let's call this g of 10. So a different function now, a quadratic function gives us a prediction of 55.2, and a linear regression function gives us a prediction of 39.3. So if this is real data, like we'll look at in class, then what we need to do is we need to have some reason for picking either the linear or the quadratic. Okay, and they both had pretty good. In fact, look, they both had 0.98. If we look back at the r squared on this, r squared was a little bit less. I don't know, it's like 0.96. Okay, and don't worry too much about what that means statistically. If you take statistics later in your life, in future years, then you'll figure that out. So that's how we can use our calculator to get a regression equation, whether it's linear or quadratic.